Hi, let us solve one lead code question today. Let me pick a random one. Sum of all subset XOR. It's easy one, and it is related to bit operations. It looks like. So let us see some medium level problem. Yeah, compare a strings by frequency of the smallest character. Let the function be the frequency of lexicographically smallest character in non-empty string s. For example, if s is this one, then f of s will be 2 because lexicographically smallest character is c, which has a frequency of 2. Okay, there are two c's, and the c is the smallest character compared to other characters. Okay, you are given an array of strings words, okay, and another array of query string queries. Okay, there are two arrays. Okay, for each query of I, count the number of words in words such that frequency uh, of that queries of I should be less than frequency of word for each word in words. Okay, return an integer array answer where each answer of I is the answer to that ith query. So this is the query. Sorry, this is query. This is word, and there will be only one element in this array because there is only one word. So this we have frequency 1, and here it is 3. The queries should be less than that of uh, any word in this words list. So we have 3 here, and of course this is 1 and less than this frequency, so it is 1. In this example we have two queries and 1 2 3 4 words, and lexicographical will be 3 only, and the frequency is 3. Here it will be 1 2 3 4. Okay, so frequencies will be 1 2 3 4, and we have 3. So we have only this word greater uh, frequency, so it is only 1. And then here C, it is 2, so we have two greater frequencies, so it is 2. On the first query, this one as expected, so they are also explaining the same thing. And on the second query, both this and this are, yeah, the question what we understood is correct. The queries will be 2000, words will be 2000 at max, and the length will be like around 10. Okay, what could be the approach or the brute force or anything, any logic that comes to the mind is so first calculate the frequency uh, of this word and find out the minimum character this and the frequency of that character, and find out the same, apply the same logic for these words also, like find out the lexicographical order, the minimum character, and find out the frequency of that, keep it ready in some temporary array, and then start comparing the values. So for in this example we will be having one array with one element that will be 1 because C has a frequency only 1, so that will be 1. And here A is the smallest character and the frequency is 3. So in this another temporary array we will be having only 3, and we will compare 1 and 3, and 1 is less than 3, so we will keep 1 here, and we have only one word, right? So this one represent the number of words in this word array. In the same way, we have one array here with values 1, 2, 3, 4, and here 3 and 2. So 3 we will compare with these numbers here 1, 2, 3, 4, and 2 and 3 are sorry, 3 and 4 are greater. So sorry, we have 3, right? So we have to compare only the greater values. So 4 is the only one word, right? So that one will come here, and 2 we have value 2 with respect to this word, so 3 and 4 will be greater than that, so we will take 2 value here. Another approach is like instead of keeping it respective values, we can sort this array, and whatever the value we will be having here, and we will do the binary search and find out the appropriate index with the greater value than this value, and with that index we can get to know the total number of elements greater than that value, and we can give that as an answer for that respective word. This is another optimized solution. But how can we do it better, or is that the final solution for this? Mm, yes, I think that we can go ahead with that logic, but there be any difficulty, one we can write one function to calculate the frequency of this word with the lexicographical smallest character uh, logic, and another function to sort out this arrays and this array values, uh, or else we can go ahead with the built-in function, and then another function to find out the index with binary search. Yeah, fine, then we can implement that. Okay, well, think about this binary search. Once we sort this one, is there any built-in function to find out the index which is equal to the value or greater than the value? Mm, or else we have to implement it on our own. Inbuilt functions, I have not used it before, so I'm not aware about that. We can build our own, we can write our own logic. So once we have queries, we can, our final result is like an array of integer array with the size will be whatever the queries we have, right? Queries length, queries dot length. So this we are going to return integer frequency with respect to queries. We can have the same array size. Okay, let us not define that here, and the frequency with words we will be having two other arrays. So let us first get frequency with respect to queries, that we calculate frequency and we pass queries. Yeah, queries, and in the same way we will calculate for frequency for words, and that time we need to pass these words. And once we do that, we will sort uh, do we have array dot sort? Java array dot sort. Okay, this will be the function. Frequency arrays dot sort this one, then we will sort this words also, and then we have to go through each and every query for int I in frequency, and then find index in frequency of words. So we need to pass I here, and whatever the value we get here, that will be, let us do it this way, equal to 0. I is less than frequency of q dot length, and then I plus plus. So here frequency q of I, whatever the value we get, that will be the result of I. Yeah. So finally we will return result. So now we need to implement this. Public int this one. What does this accept is string of array of string. String array. This will, we can call it as words. So we are going to return one array result that will be new int of size words dot length, and then for int I equal to 0 and that words dot length and I plus plus. So we got one word now. We need smallest. We can go ahead with for example, we can character C we can initialize with value, we can say it as C, and integer count as 0. So we will assume that Z is the smallest character that we found and the count is 0. We need to check now with other character, with all the characters now in this particular word, ith word. So for characters ch in this word, words of I dot to character array. If that ch is less than c, otherwise first we will compare whether it is equal to c, then we will just increment the count. Else if we will see whether the ch, the whatever the current character is there, then that is less than the c what we thought, what we considered earlier, then our c becomes ch and the count will become 1. If it is greater, then we just ignore them. So once we do for all the character, then res of I will be count. So this count is not reachable here, so we will have to declare it outside. And count will be 0. Once we do that, till here everything is fine. Now we need to implement this method, and the input will be this integer, but we are passing frequencies value, queries frequency value, that we need to find the greater values in this. So along with this we need to pass frequencies of word. So now we will declare another function like this. So this will be integer, this will be our key. This will be integer array, values or numbers we can say. Now integer made low will be 0, high will be this numbers dot length, and the mid is equal to low plus high by 2. Now we will go through the standard binary search algorithm. If low is less than equal to high, then we will come inside, then we will calculate mid, the same approach, same formula. Then if our key is equal to numbers of mid, then we are done. We need to return the length. So we should not consider the equal value, so return the numbers length minus the mid value, then minus 1. Right? For example, if we have 5 values, then the length will be 5. Consider we found at index 2. 5 minus 2 will be 3. Then we are supposed to send only the higher value, so it will be minus 1. Otherwise, if the key is less than the number of that mid location, mid index, then we will say we just need to update the low. Right? The key is less now. Key is less, not the array value. So the key is less than, sorry, so consider we have 5 values and the mid value is when the values are 2 3 4 5 6, for example, 2 3 4 5 6, these are our 5 values and the mid will be 4, and consider our key is 3. In that case we have to end up here, right? So we are supposed to ignore this one, and the key is less than this one, so we are just need to update the low one. We need to update the higher index, so that we have to consider only this part. So we need to update the higher index. High should be updated to mid -1. The other option will be less, else we just need to update the low. Low is equal to mid +1. Once we end up, for example, we have 3 5 7 9 and 11. Consider we have key as 4. In that case, first we will compare a key and mid value. This is not equal, so the key is, we have key as 4. So in this example key is 4 and we are comparing 4 and 7. Key is less than the mid value, so high will be updated to this location. We have only 3 and 5. Low is pointing here and the high is pointing here. Now the mid will be 3, because 1 plus 2 is 3. 3 by 2 is 1. Sorry, this is 0 and 1. Sum will be 1, so 1 by 2 is 0 again. So this will be our mid. So again in 3 and 4 are not equal, so this again in the second iteration this will not be executed. The key is not less than the mid, because key is 4 and this is 3. So we will come to the else part. This will be here. Now we will compare again. So if it is higher, okay, now we came to this location, we just compare these two values. Now this is not equal, this is not less, key is not less than that one, and again we will update the low. Now the low will be here, but now here this condition doesn't satisfy, so this will be, iteration will be broken. Now we are supposed to return, so anyway the our mid will be pointing here. So numbers dot length minus mid inside, I think. So we are supposed to return 4. So mid will be pointing to 1. So we have 5. 5 minus 1 is 4. So that we are supposed to return here. Otherwise, consider what value can we take? Example, if it is 5 only, then this will be executed. If it is 6, then it is greater, so somehow we will end up here. Let us see with 6. So we will compare 6 and 7. This is not equal. Key is of course less than this one. We will go to the, we will move high to mid minus 1. So we came only to this part, and now mid will be this one. 3 is not equal to 6, so even the key is not less than mid location value, so low will be incremented to this one. And now 6 and 5 are compared, it doesn't match, so low will be incremented to this, and this location, this condition breaks, and now the mid is pointing here. So number length minus mid will be, again it will be 4, right? So 5 minus 1, it is 4, but actually we are supposed to get 3. So the condition, we have to check the condition. What is the condition? Is like if numbers of that mid is that greater than key, okay, if that is greater than key, then we will return this, otherwise we have to return -1. Hope it is clear with the example that we saw. In case of 4, we have to consider 5 because that is greater. In case of 6, the mid is pointing to the same location but the value is less, so we need to ignore this one, so we just need to return 3. So that purpose we will do -1, so that value will come here and that we will store. Let us see if there are any compiler error. Yeah, oh yeah, we need to comment out these two better. Okay, incompatible types int cannot be converted to int. We did use array. Line number 13. Yeah. Frequency of I. Frequency of I is integer, and here it is also integer. Sorry, find index in frequency of W. W integer. And this one is array, and here also it is array. Is like this. And incompatible types in cannot be converted to integer array, and the line number 48. Number 48. Yeah, we are not supposed to return here. Instead, we can break the loop, and that condition will be checked here again, and then return this 59th. We are supposed to return an integer, and incompatible type cannot be converted. This will be fixed. Let us see what was the error with this. Returning a missing. Okay, we are supposed to return the result here. Yeah, we got the expected result, but for other example, wrong answer. So we got 2 1 and this is 1 2. Okay, expected is 1 2, but we got 2 and 1. Mm. So the other example was this one. This is 1 2 is the expected, but we got 2 1. Okay, let us see what went wrong. Why did we get 2 here and why did we get 1 here? Is it because of this logic? So we have 3 and here also we have 3, and that was matching somewhere. We have proved that condition, we reached this condition and we came out because mid was pointing here, and we did not check whether it is equal or not, right? Okay, if that is equal, then we have to return this one. Yeah, then it is correct. So it is, in this case it is 3 and we also have 3. Then we are, oh, 1 second, we are not supposed to sort the queries, right? Let us see now. Now we got the expected result, but can you can we test with some other approach, some other test cases? For example, if I say IED and then values, let us see. Wrong answer. Expected was 3 but we got 4. In this case E is 2 and here we have 1. So this is also 1, this is also 1. We have 2, so 1 2. What's exactly happening here is like D is the smallest, not E. D1, that is, we have to skip this one and this one. We have only 3, so that should come here. We are putting 4. What exactly was happening here was we have calculated, but we have sorted also. In that case, we got is 1 1 2 3 4. 1 1 2 3 4. We will 1 1 2 3 4 and our key is 1. In that case, low was here, high was here, mid was here. Mid is not equal to this and key is less, so our high will come here. These two, mid is this is equal. Okay, this has become equal now, but we are supposed to go till here. If it is equal, yeah, then we have to break, but we have to go to the last index and see. Instead of breaking, what we can do is, let us move our low to the mid plus 1. So in that case it should pass, but will it affect to the other conditions? No, it will not affect, because if there are duplicate values, then definitely we have to go to the last index. We got expected result, but with other conditions, with other examples, yeah, it works. Mm, any other corner cases that we missed? I can submit for this approach, but what if uh, the value is completely greater than the of these values? Example is a. We should get 0 of bound. Why we got out of bound is what happened here. These are queries, these are words, and numbers. This is part of this function is being called with words. Yeah, words. Then why was index out of bound for 4? Okay, this value is completely greater than all these values. So, our high should be length minus 1. Yeah. Let us submit. Wow, successful. Yeah. And it is faster than almost 70%. We should not end here without seeing the other solution. So array sorting straightforward solution. So what they are doing is they are also creating two arrays. They are chucking, they are sorting. Oh, initially only they are sorting the characters, and then they are counting unless the words. So sorting takes n log n time. If you do not sort and just go through all the characters and find the minimum character, keep track of that, that will take O of n. So that optimization we have done, and then I think they would have followed the same. So they again sorting the characters in the word. So this is for the words array. Again the same logic as we saw here. Instead he could have written some function for this instead of repeating the same code. And then he go through all the words in the array of that words, and then he will just increment. So even this optimization we have done. 99% they are doing is they will take words length array and they will calculate the frequency. They have written some function. What was that function is they will take the first character as the smallest and they'll take the count as 1. So this is better instead of making z and 0 count. And then they'll iterate through the other characters, and if it is small then they will link as we have did the same logic. They applied, and they are returning the frequency. Once they get the frequency, they are sorting these values. Yeah, even we have done the same thing. uh, they will create one answer array. Maybe they are at final they are returning the same array. They will go through the frequencies, they will calculate the frequencies, they will uh, I think it is binary search as we have did. U plus 1 f low and high. Then this f they will keep its binary search. U plus 1 is okay. Low and high is indexes of that array, and u plus 1 is that frequency. Instead of writing a lot of if conditions, what we have written to check whether it's equal or greater, then we just increment the value and find out that particular index. Even this is nice logic. And what is ff here? Naming convention is not great. If okay, the frequency of that word, that array they are sending. Okay, same looks same logic they have written in very few lines. This is interesting, right? So return, they have written it in recursion, not iteration. Yeah, fine then. This looks great. Let me stop the recording.